Alright, today we're going to do worksheet 3, mole conversions, single step. Now these take a while to do, so this is going to be a long podcast. So what you should do is look at the problem that you're trying to solve and find the area of the podcast to watch, so you don't have to watch the whole thing. Alright, how many atoms are in 1.5 moles of neon? Well, what we're doing is we're converting from moles to atoms. That means we use the 6.02 times 10 to the 23rd conversion factor. So that means I take 1.50 moles of neon, and I have to get rid of moles of neon, and I have to go to atoms of neon, and for every mole there's 6.02 times 10 to the 23rd atoms of neon. When I multiply this out, I get 9.03 times 10 to the 23rd atoms of neon. By the way, folks, your answers are not complete unless you have units, so make sure you put in units. All right, how many moles of sulfur hexafluoride are there in this many molecules? All right, well, what I have to do is it's a lot easier for me to convert this into scientific notation, so I'm going to say 4.595 times 10 to the, 3, 6, 9, 12, 15, 18. That's the 18th. And what I want to do is I want to take this, and these are molecules. And I want to go 6.02 times 10 to the 23rd molecules of sulfur hexafluoride. And 1 mole of sulfur hexafluoride. So, when I do my division, if you do it right, and guys, this is where you go back to the podcast and look at how you do your calculator correctly, your answer is going to be 7.633 times 10 to the minus 6th moles of sulfur hexafluoride. Right, how about number 3? Calculate the number of moles in 5.45 times 10 to the 25th atoms of zinc. And now I'm converting from atoms of zinc to moles of zinc. And for every mole, I have 6.02 times 10 to the 23rd atoms. When I do my division, again, you have to make sure that you use your calculator correctly. We're going to come up with 90.5. Let's try that again, 90.5 moles of zinc. All right, what's the mass of 7.5 moles of sulfur dioxide? Well, this is actually a two-step problem. You have to be careful here. You have to figure out that sulfur dioxide is SO2. So what is the molar mass of SO2, of 1 mole of SO2? Well, 1 mole of SO2 would be 32.066 plus 15.999 times 2. When I go and I multiply that out, I get a total of 64.064 grams per mole of sulfur dioxide. All right. So then what I do is I take my moles of sulfur, which is 7.50 moles of sulfur dioxide, and I have to get rid of moles of sulfur dioxide, and I have to go to grams of sulfur dioxide. And for every mole, there's 64.064 grams of sulfur dioxide in 1 mole. So I multiply this out, and I get 480, notice the decimal point, grams of sulfur dioxide. That decimal point is important. Why? Because we have 3 digits of precision in our problem. We need 3 digits of precision in our answer. If I just said 480, that would only imply 2. Right. How about number 5? How many moles are there in 250 grams of sodium phosphate? Well, let's figure out sodium phosphate. Sodium is Na, phosphate is PO4. What are my charges? +1, -3. I cross them, so it's Na3, PO4. So I have to say Na, which is 22.990, and I have 3 of them, and my phosphorus, which is 30.974, and I have 1 of them, and oxygen, which is 15.999, and I have 4 of those. I have to multiply all those out, add them up, and I get 163.94 grams per mole. Now I can start with 250.0 grams of sodium phosphate. Before I go any further, note that I have 4 sig figs here. And I am going to get rid of grams of sodium phosphate and go to moles of sodium phosphate. And 1 mole is going to be 163.94 grams. So when I do the math here, I come up with 1.525 moles of sodium phosphate. That's my answer to number 5. Right. Number 6. How many grams of potassium sulfate are there in 25.3 moles? So again, I have to figure out what the formula is here. Potassium is K, sulfate is SO4, and potassium is a +1, and sulfate's a -2. So I cross them, so that means I need K2SO4. So I look up K on the periodic table, it's 39.098. And I look up sulfur, which is 32.066, and oxygen, which is 15.999. I have 2 potassiums, 1 sulfur, 4 oxygens. I multiply and add, and I get 135.16 grams of K2SO4 in 1 mole of K2SO4. Right, so now I can go and do my math, because I'm given 25.3 moles. Gee, that's a lot. 25.3 moles, and I'm going from, right again, 25.3 moles, and I'm going from moles to grams of K2SO4, and 1 mole is 135.16 grams, so I multiply those together, and I get 3,420 grams of K2SO4. Right, how about the end, the last one on the page? We calculate the number of grams in 3.25 moles of silver nitrate. Silver nitrate is Ag, silver, NO3, nitrate, +1, -1, they cancel each other. So I have to simply add up my numbers. So this is 107.87 for silver, and nitrogen is 14.007, and oxygen is 15.999 times 3. I add all those together, and I get 169.87 grams per mole of AgNO3. I now have to convert from 3.25 moles of AgNO3, and I get rid of moles of AgNO3, and I go to grams of AgNO3, and I realize that for every mole of AgNO3, I have a mass of 169.87 grams. So I multiply these together, and I get 552 grams of AgNO3. All right, so let's keep going. Next page. So what's the volume of 0.38 moles of any gas at standard temperature and pressure? Well, you have to know that there are 22.4 liters of gas at standard temperature and pressure in 1 mole. So we start out with 0.38 moles. The gas doesn't matter, and we're going from 1 mole of gas to 22.4 liters. So all I have to do is multiply those together, and I get 8.5 liters of gas. All right, how about if I start with 32.2 liters? Well, 32.2 liters have to get rid of liters, so liters goes on the bottom and moles goes on the top. The fact that it's ammonia gas makes no difference because it's any gas. And so I take the 32.2, I divide by 22.4, and I come up with 1.44 moles of ammonia. How many moles are in 51 liters of oxygen gas? Well, again, it doesn't matter what the gas is. We start with 51 liters. We divide by 22.4 liters in 1 mole of any gas. And our answer here is going to be 2.3 moles. All right. How many moles of barium iodide contain 4.24 times 10 to the 24th formula units? Right? Well, clearly we're starting with things, and we're trying to get to moles. So we have 4.24 times 10 to the 24th, and those are formula units. And I want to go from formula units to moles. And for 1 mole, there are 6.02 times 10 to the 23rd formula units. Right? And you might think of these as molecules. They're really not because they're ionic, but we still use the term formula units. And if you do your math right on this one, you're going to come up with 7.04 moles of barium iodide. All right, number 12, find the mass of 0.159 moles silicon dioxide. So for silicon dioxide, I have to figure out what its mass is. Silicon dioxide, it's covalent. So silicon is 28.086. Oxygen is 15.999 times 2. I add those up and I get 60.084 grams of silicon dioxide per mole of silicon dioxide. Okay, so I start with 0.159 moles of silicon dioxide, and I'm going from moles of silicon dioxide. I'm going to grams of silicon dioxide, and there are 60.084 grams of silicon dioxide in 1 mole. I'm going to multiply that out, and I come up with 9.55 grams of silicon dioxide. All right, on to number 13. Find the number of liters. Oh, that's real easy. We're talking about STP, so this is no additional calculation. 2.64 moles, and I'm trying to go from moles to liters, and it's 22.4 liters in 1 mole of any gas. So I multiply these out, and I get 59.1 liters. Number 14. Formula units, moles, piece of cake. 688.688 moles of silver nitrate. We go from moles to formula units. Moles is 1, formula units is 6.02 times 10 to the 23rd. So we multiply all this out, and we get 4.14 times 10 to the 23rd formula units. All right, that's the second page. Let's go on to the last page. A bottle of potassium permanganate. We're talking about grams here, so we're going to have to go and figure out how many grams potassium permanganate is. Potassium is K, permanganate is MnO4. That is a +1 -1, so all I have to do is add them all up. So potassium is 39.098. Manganese, this is not magnesium, this is manganese. Manganese is 54.938. And oxygen is 15.999. I have to multiply it by 4. So I multiply and add the whole thing up. I get 158.032 grams per mole. All right, so now I can do my math. And I say 66.38 grams of KMnO4 have to go from grams to moles of KMnO4. And in every mole, there are 158.032 grams. So my answer when I do the math is going to be 0.4200. Wow, why those zeros? Because I had 4 sig figs up here. 0.4200 moles of KMnO4. Alright, number 16. We have liters, we have moles, piece of cake. 101 liters divided by 22.4 liters in 1 mole, and we get 4.51 moles. 17. How many moles of potassium permanganate, we're back to that one again, would contain this many formula units? Don't need to worry about the mass here. So you always start with the information you're given, which is 2.43 times 10 to the 23rd formula units. And I want to get rid of formula units, and I'm going to moles. It's always 1 mole, and the formula units are 6.02 times 10 to the 23rd, Avogadro's number. When I do the math, I come up with 0.404, or 0.04 moles of KMnO4. How about 18? Ooh, we have barium nitrate, and it's grams, so we have to figure out how much barium nitrate weighs. Well, barium is Ba, nitrate's NO3, and I have a 2 plus charge and a 1 minus charge, so they crisscross, so I have to have 2 nitrates. So it's BaNO3 2. So Ba is going to be 137.33, and nitrogen is 14.007, but I do have 2 of them, so I have to multiply that out. And oxygen is 15.999, and I do have 6 of them. When I go and add them all together, multiply them out, I get 261.34 grams per mole of barium nitrate. So now I can do my problem, which is 6.8 grams of barium nitrate. And I have to convert from grams to moles of barium nitrate. And for every mole of barium nitrate, that weighs 261.34 grams. When I do the math, that comes out to be, place to write, thank you, 0.0260 moles of barium nitrate. Alright, 3 more problems. A vial contains this many liters, and we're going from liters to moles. Piece of cake, 0.03254 liters. And I want to get rid of liters, so I put liters on the bottom, go to moles on top. Liters is 22.4, moles is 1. So my answer is going to be 0.0. That doesn't look right. I think there's another 0 in there. 0.001453 moles. Yeah, I'm thinking that's right. I might be off by a factor of 10. Alright. On to number 20. Determine the number of formula units that are in this many moles. Well, formula units, 1324 is moles, and I'm going from moles, and I'm going to formula units. It's 1 mole, and it's 6.02 times 10 to the 23rd. Formula units, I multiply that out, and I get 7.970 times 10 to the 23rd. Okay. Really? Sorry, there isn't number 21. So I'll do it on here. Find the mass of 0.890 moles of calcium chloride. Calcium chloride is CaCl2. Calcium is 40.08. Chlorine is 35.453. But there are two of them. So I have to multiply and add, and I get 110.99 grams. And find the mass of 0.890 moles, so 0.890 moles. And I go from moles, grams, 110.99 grams in 1 mole. I multiply it out and I get 98.8 grams of calcium chloride. Now I'm done. That's it. See me in class if you have questions. Have a good one. Bye-bye.